talk about the history of how technology diffuses and what that means for blockchain. So, is there really any difference between the phone on the left and the phone on the right? I mean, is there any real material design difference between the two dominant and most commonly used phones? I would say no, right? I mean, what's happened is, since the very first iPhone, there really hasn't been much fundamental change to what a smartphone looks like or how it operates. There are more apps, there are more capabilities, they're faster, they have better screens, they have better cameras, but the fundamental design of the two leading phones today is basically the same as where it was, 10, 15 years ago, right? And this is something that we see frequently in product and technology markets. In fact, this dates all the way back to 1894 and the concept of the running machine, which is a design that's still today something that we'd recognize as a bicycle, right? And so this is a frequent occurrence that once a technology gets to a certain amount of maturity, it gets heavily imitated and standardized, right? Now, this concept was promoted not by the band, but in 1975 by Uranaki and Abhinath, who wrote this theory called dominant design, observing how technologies evolve and become de facto standards, right? And so we've seen this already in our space, with Bitcoin providing Merkle proofs, tokenization, and crypto economics as key ingredients into the dominant design of what a blockchain is today. Obviously, Ethereum added in a layer of smart contracts, which is getting replicated in many of the other systems that we see. And we're now going through a period of re-experimentation, imagining how these networks continue to increase in scale. But if you look at the design patterns behind Dfinity, Oasis, Serenity, the various technologies that are out there, they all have a lot of commonality, right? They all rely on the separation of the core trust chain from the state execution, from the state execution, from the data storage, right? And so these are common patterns that we're seeing, right? And so why does one win or the other, right? Why AC, not DC? Well, the answer typically is not because one technology is better than the other, but it's because how the other set of problems are solved around the technology, what's called reverse salience, right? So in the case of electricity, there were two key issues that happened. One was low power DC was very hard to distribute, right? Whereas you could distribute AC and then convert it down, step it down. And the second one was the power cables, and this was about broader adoption regardless of the current. The power cables were initially laid in the ground and had two problems. One, they frayed, and two, they killed people. And so the invention of the utility pole was absolutely critical to adopting electricity in cities, even though there's almost no technology in it at all, right? It's a pretty dumb thing, yet it was critical to how electricity was adopted. So what does this mean for a software ecosystem? Well, what it means is there are many things other than the core protocol or the core programming language or the core underlying technology in order to get adoption. Development tools. I come from a certain religion. Some people come from the other religion and they're just really weird. Hands up if you're old enough to understand that joke. Okay, 2, that's not good. This is Emacs. The other thing's just horrible. Someone else recognized that. Okay, so what starts to happen is you start to need other things other than the core technology to be produced in order to be able to actually adopt the technology. So in the case of the internet, these two tools, on the left, Mosaic, hands up if you used Mosaic. Right, same group of people of the VI Emacs camp breaking down. And who used Yahoo when it was still hosted on the Stanford CS website? Right, and so these two tools really were critical for how the first few tens of thousand users actually got on the web and communicated, right? Now, the internet clearly has grown exponentially fast since then, right? Up to 3.5, 4, maybe 5 billion people today, right? And what's interesting within this is looking at how did the internet scale? If we want blockchain technology to truly scale, what is it that enabled what is it that enabled it? And the answer is, and this is to quote Albert Barabasi, it's no central node is in the middle of the spider web, controlling and monitoring every link and node. There's no single node whose removal could break the web. A scale-free network is a web without a spider, right? And this is something obviously that's near and dear to our space in terms of how do we take the concept of the traditional web and apply it to transactional systems so that we can build transactional systems where no node is key, which is laudable in principle. But if we look behind the internet in fact looks like this. While there's no central node, right, any node can be removed from this and the network will keep operating. Some nodes are much more heavily connected than others. And there are reasons for this. The major reason is it decreases the number of connections you need to traverse the network, right? And so it turns out if you have a random network and you add just a few edges, you are able to reduce the degree of the network from 6 to about 3.5, right? By adding a few extra edges, which leads to node concentration, right? And so what's observed in these networks that scale very, very quickly are called scale-free because the design of the network is able to be maintained regardless of the size of the network, is this. And look, some people probably can read this and visualize what it means, but what it says is the degree of any node, so the number of connections a single node has within the network, is distributed by a probability function which is inversely proportional to the number of connections it has. Or, easier to put, it's a power node. There are many nodes with only a few links and a few hubs with a great number of links, right? In real world, this is what high-scale networks look like, right? And one of the challenges we have today in blockchain networks is they're entirely peer-to-peer, and so that we're limited to a certain extent to a certain number of operations per second, right? By the way, if you want to read more about it, pick up either one of these two books that explain how network theory maps onto exponential growth. So scale-free blockchains, we can think of this as a internet of blockchains. That if we want to achieve global scale for blockchain infrastructure, then we're going to start to see network topologies develop that look something like the internet itself. A scale-free network where any arbitrary node could be removed for sure, but various parts of the network interconnecting, right? This is what will allow us to get to that point. And fortunately, if we look at the next generation designs, right, whether it's in Ethereum 2 or in Definity or in Oasis or several of the others, we're starting to see the ability of adopting underlying technology architectures that enable scale-free network topologies, right? And this is really a big deal in terms of being able to achieve the global levels of throughput you need to do something like run Visa on Ethereum, right? So then the question becomes, well, which one of these next generation protocols is going to really achieve the necessary adoption to get to that exponential growth curve, right? And this is where we come back to the power pole, or to Emacs, or to the browser, or to Yahoo, which is the issue is not going to be which base technology is better implemented, right? What's going to matter is which base technology has the better ecosystem and the better set of tooling around it that allows for the first tens of thousands, hundreds of thousands, millions of users to be able to actually use the technology in a productive way. And so, which leads us to the ability that to get to this internet of blockchains, what's going to matter is how we scale the underlying ecosystems. And obviously, us at ConsenSys have a view on how that's achieved and are heavily involved in trying to do that with Ethereum. So the future of blockchain, I believe, looks very little different than the history of other scale-free networks, right? And I believe that we're at the point in time where we've already seen the dominant design for layer 1 establish itself based on Merkle trees and smart contracts, et cetera. And we're starting to see the architectures evolve around that allows for scale-free networks to evolve on top of that base trust layer, right? And in terms of Ethereum, I believe we've seen a sufficient emergence of an ecosystem of tools around that to solve for many of the reverse salients required in order to build a future of the decentralized web. And so, go Ethereum.